All right, guys. First thing that we're going to do today is we're going to write down our learning targets. So today, find Wednesday on your math accountability sheet, and I want you to write this down. Somebody want to read it for me? Okay, Jake Bell, read this out loud for us.
I can make equivalent fractions and explain those fractions using models, numbers, and words.
Right, so we're not just making an equivalent fraction. We are creating an equivalent fraction. We're doing it with models. Those are our fraction rods. We're also going to do it with numbers, where we say like 1/2 equals 4/8. And then we're also going to do it with words, where we explain what we're doing. So I'm going to give you about a minute to write that down. And then after you do that, you can kind of put that away for a second, and we're going to get started on the lesson. Okay, guys, what I want you to do now is I want you to take out your fraction rods, and I want you to do this. See number 1 up here? I want you to find the dark green rod. Now make sure that you're not finding the lime green rod, but you are finding the dark green rod. That will mess you up, okay? Dark green rod. Alright, dark green rod out on your desk. Okay, so let's think about this question here. How many white rods does it take to equal the length of the green rod? So I want you to figure that out. Using your rods, how many white rods does it take to equal the length of the green rod? Raise your hand when you know. Drew knows. David's got it. Okay, Taylor's got it. Kyle, lots of people are getting it now. And some of you even had it when there was only one rod. Okay, so tell me, Arya, how many white rods does it take to equal a green rod? Okay, 6. Thumbs up. Everybody agree? Okay. Now, let's look at this next question. We're going to take it a little bit farther. What fraction does one white rod represent when compared to that dark green rod? So if we pull out 1 from our little line up there, what fraction does it represent, Drew?
1/6.
1/6. Now, why did you say that?
Because there's 6 little rods.
Okay, he said 6 little white rods make up the 1 green rod. Okay, well, think about this question. Why do you think I added the phrase when compared to the dark green rod in that previous question? Why did I put that? Why didn't I just say, what does 1 white rod represent? David?
Because the green rod is only one hole. You could have different holes, like the round hole, and that would mean it would not be 6.
Right. Okay, so if there were a different hole, then it's no longer a 6th, right? Because that hole is a different length. So I like that when you were explaining that it was 1/6, Drew, that you said 1/6 of the dark green rod, right? Because it's not just 1/6. We don't just walk around on the planet, see one of these and go, that's 1/6. That wouldn't make any sense. It's out of context, right? We have to have that hole to know what we're talking about. So let's look at the next one. Which rod in your set, now you're going to have to get a different one now. Which rod in your set of fraction rods represents 1/3 of the dark green rod? So we've done the 6 pieces. Now we're finding one that represents 1/3. Which one takes 3 pieces to equal the length of the green rod? Harley?
The red ones.
The red ones, okay? Thumbs up. Everybody with me? Now, Harley, why did you choose the red ones?
Because they're two of the white squares.
2 of the white squares. Okay, good, and I like where you're going with that. What else, Jake Mayfield?
Because I already know that my multiplication factor 2 times 3 equals 6, and these are 2 blocks long. And so if I put 3 of them down, it's going to equal 6.
Right, and I love that thinking. Do y'all hear what he's saying? Do you see how he brought in the word multiplication? Now, if I said that, if I said multiply or anything like that, no, but Jake is already seeing, wait a minute, there's some kind of multiplication connection, and we're going to talk about that in just a minute, okay? So he says there are 3 there. What about how many white rods equal 1 red rod? Well, this was just answered. Jake, you already went into my next question, and so did you, Harley. Angelina, how many white rods equal the red rod? 2. Okay, now, could we say this? Look at this question down here, number 7. Could we say that 1/3 equals 2/6 in this situation? Okay, well, somebody tell me how you know. How can you explain that? Madeline?
Because the 1/3 is 1 of the red, and the 2/6 is 2 of the white, and they are the same height.
Exactly. So immediately when I said that, here's what Madeline did. She pulled out 2 of the white and 1 of the red to show that 1/3 is equal to 2/6, right? 2/6 pieces. They're the same length, the same amount. They line up perfectly. All right. Now, let's change this up and let's do a little scenario, okay? Raise your hand if you like Airhead candy. Me too. My favorite Airhead candy is the green apple. Okay, so this green rod, now don't eat it. I mean, you break your teeth, we'll have all kinds of trouble. But that green rod today represents 1 piece of Airhead candy. Okay, so suppose that I ate 1/3 of it. So I take a bite and I bite off 1/3 of the candy. I could also say another fraction to represent that amount. I want you to use your rods to tell me, and some of you already know, but I want you to prove it with the rods. Show me another fraction there that could represent the same amount. All right, Jimmy, what do you see?
2/6.
2/6. So he put these 2. He's getting another fraction. He knows these are 6 pieces, so that's going to give us another fraction. And 2/6 is the same length. So if I bit off 1/3, I also bit off 2/6. It's the same amount. Okay, now, suppose I ate 2/3 of the Airhead. Okay, so look, here's my 2/3. Now, what's another fraction I could use to represent that 2/3? Read.
4/6.
4/6. How do you know?
Because 2 of the white blocks take up 1 block of the red, and there's 2 blocks, so 2 times 2 is this.
Okay, good job. Now, let's think about something else. Okay? Keeping in mind. So, a minute ago, we started thinking about multiplication. Remember I told you, I said, Jake, you are going where we're going with this. Okay, so I want everybody, though, take a look at this. Because we may not all be there where Jake is with this, and I would certainly not be when I was your age. I had to see it a lot more. So let's look at this. 1/3 equals 2/6. We proved it a minute ago, right? 2/3 equals 4/6. We proved it. Do you recognize a pattern here? All right, David, what do you see?
That if you double both of the fractions, they will both equal each other. So, you could probably, well, no, not with the thirds.
You're going in the right direction.
If you double the thirds and double the 6 again, you can't do that, but if you could, then they would be equal.
Okay, so I see David right now, he's kind of, it's starting to come to him, he's starting to see it, but he can't quite get the words on it. So I'm going to add another question, okay? And let's see if he can clear it up now, okay? So what if I said this? Everybody line up all your green trains, okay? So line up the red trains on the green one and line up the white ones. You can also pull out your lime green. Everybody line that up and look at the whole model for the dark green hole. Okay, so line them up. So you should be using white, red, and lime green. Now look at this question up here. It's number 11. Could we say there are 2 times as many white rods as red? Count your white rods. Count your red rods. That's a tongue twister. Could we say there are 2 times more white than red? Do you see that? There are 3 red rods, correct? 3 times 2 would be 6. Okay, now look at this. Could we say there are 3 times as many white rods as lime green? How many lime green rods are there? 2, so those are halves, right? So 2 times 3 equals 6. Okay, do you see the multiplication starting to come? All right, now we are going to move away from this example and you're going to do something. So I've been telling you what to do, telling you what to do, telling you what to do, and now it's time for you to show me, okay? At the end of the lesson, I'm going to give you an exit ticket and we're going to see, did you get it? Can you make equivalent fractions and explain those fractions using models, numbers, and words? Now, you have chart paper in front of you. Everybody's working together. Now, let me go over a few things before you start, okay? First things first. Remember when we first started drawing fraction models and we had all kind of trouble with people trying to trace them? Why is tracing... Now imagine, if you will, you're taking your orange rod and you're putting it on this chart paper and you're going to trace it. Why is that not a good strategy for drawing your model, Harley?
Because if your graph paper is bigger than your stick, it won't have...
Right. Are those squares on your graph paper exactly the same size as those tiny little white ones? No, bad strategy. So look up here. Remember, we have this anchor chart. It says when we're drawing our models, the first thing we do is use the white blocks, right? So if you have a strip of 10 white blocks, you're going to use that black marker in there to outline every single white block, right? But we don't have to color them white because the paper's white. Then you're going to create your hole on top of that. And we have an example up here. So if you get confused when you're drawing your model, because we are trying to be precise. We are using models, and we know that models only help us if they're precise, right? We have seen when we have tried to draw models before that they don't always show us. Think about when we tried to draw these, and they were a mess, right? Because they weren't precise. So we're trying to be precise so that we can look for and make use of structure. So we're trying to do these things that we've talked about. Everybody right now, if you would, get the real world scenario sheet from in the center of your table and let's talk about it. And then I'm going to let you go. Okay, now, let's read this scenario. So this is a real life application for equivalent fractions. So here we go, real world scenario. The Helena High School track team is participating in a long distance trail running event this weekend. So they are running on trails. The event takes place at 3 different high school running trails. They're not all going to the same place. So different team members are going to be going to different places. And you guys have probably already noticed on your chart paper that you are going to a certain school, right? Jason, Jill, Anna, Joe, Stacy, Rodney, and David are all participating in the event. Okay, let's look at Team A. Raise your hand if you are Team A. Okay, Team A, we should have another Team A over here. Okay, so Table 1 and Table 5, they're Team A. So y'all are following Jason and Jill. Jason and Jill will be traveling to Hoover High School to run on the 10-mile Orange Trail. We're going to talk about why that color is important in just a second. Now, raise your hand if you're Team B. Table 2, and table 4. Okay, y'all don't have far to go. Y'all are just going to Helena, okay? You are going to be following Anna and Joe and going to the Helena track that is 9 miles, and it's called the Blue Trail. Team C, where are you? Right here in the middle. You guys are going to be going to Pelham High School, and y'all are going to be watching Stacy, Rodney, and David. Y'all have an extra person. They're going on the Brown Trail. Now, what do you think? Why did I just choose those colors? Orange, blue, brown. I just pulled those. Do you think those are my favorite colors? Why, Oscar, do you think I used those colors? Okay, well, you're talking about they're the biggest rods, right? Which means they have more factors, which means they have more fractions, right? But why, Drew?
Because the orange one takes 10 little white squares, and then the blue one takes 9 white squares.
Right. Why did I not say use the sparkly purple rod? Do you have a sparkly purple rod in here? No, we're using these fraction rods to represent the whole. So which rod represents the whole for the people going to the Hoover 10-mile trail? Demir? The orange. Which rod represents the whole, Reed, for the people going to the Helena Blue Trail? Blue. Which rod represents the whole for the people going to the Pelham Brown Trail? Jake Bell? Yeah, it's like so easy that it's making you like, what? Does she want me to say brown again? Yes. Okay, so if you turn it over, we have all of our scenarios on the back. You are going to work to answer the questions about your people that you're following. Now look, if, for example, I have already put this problem at the top of your page. Everybody see you've got your people there. So like this one is Jason and Jill because they're going to Hoover. So the first thing you're going to do is build your model. Down here you're going to draw your model. Here you're going to use numbers to represent it. And here you're going to use words. Give me a thumbs up if you're following me. All right, now listen. You have to know what you're talking about because at the end we're going to come up here and we're going to share it. Okay, and you don't have super long to do it. Okay, so don't just sit there and think, what are we having for lunch today? What am I going to do this weekend? I mean, it needs to be like, let's think and let's get on this, okay? So you will use your rods to do it. You will all work together. You have a black marker to outline different things. And then you got to be ready to defend it when you come up here. So if Jimmy is talking about Angelina's work, he may ask her a question. You need to be prepared. You need to know what you're talking about on here. So you need to be working together. Thumbs up. All right, you may start. All right, why did y'all draw this that long?
Because it took 9 little squares.
Okay, and you're sure? You checked it. Okay, so the whole, and then you have 9 individual squares to represent the whole. And you lined them up and checked them so that you could prove it, right? All right. Okay, so Jake, I see you over here, and y'all are all pretty much doing the same thing. What are you doing right now? Explain it. Building the brown train. Why? Right, you're going to need several options, right? Okay, are y'all following the same line of thought here? Okay, now remember, you are all working together, so just because you're sitting by someone and it's not just partner work, we can be working together, okay? All right. Where are you guys starting? With the blue rod? Yes, you can. Okay, so what are we doing right now? Where are y'all at with this? Okay, so you're building your fraction trains, right, for blue. All right, here's the question. Why are y'all using the orange rod and not a different one? You're right. I just want to know if you know how to explain it. Because it uses 10, but also because that's our hole. Right, the orange trail.
What do we have to do here? I'll just use it. I'll draw the red.
Okay, now, are y'all sure that you found all the trains for that piece? Do the lime green pieces work? Why? Why don't they work, Tanner? If you use 3, it goes over. Okay, so it doesn't match up exactly, right? And it has to. All right, are y'all building the trains? Okay, snap once, snap twice, snap 3 times. Okay, as I'm walking around, I'm noticing several of you, you're all pretty much building your fraction trains, which is good. But here's one thing we want to make sure that we've done. We want to make sure that we have read our question. So right now, I want everybody to take a second and read your question. So Harley, read it aloud for your group. Destiny, read it aloud for your group. Read it aloud. Aria, read it aloud. And Ethan, read it aloud. Okay, so everybody, let's go back to the question. Make sure we're not just getting off on a tangent of building things so that we can focus our work. Okay, so read it. Go.
Okay, so we just did this. And arranged their life trail. Joe ran this and just takes her and they connect the different fractions. So that would be 2/6.
Okay, well, let's look at this though, okay? Show me 2/3. Okay, there's your thirds pieces. How did you know those were your thirds? But how did you know that these were called thirds? The green ones. Right, because there's 3 of them. And we ran 2/3. So let's pretend like this is our starting. Yeah. Okay, so we've got these 2 kids, Anna and Joe. They're running. She ran 2/3. Okay, he's stopping at the same place she is. So maybe this is what Joe ran, right? So he ran from here to here. So what are these pieces called? Ninths. Okay, and 1, 2, 3, 4, 5, 6, 7, 8, 9. So they're ninths. How many of those did he run if he ran the same amount as her? They both stopped here. Okay, she ran 2/3. So let's look at this. How many did he run? 6. Ninths. Okay, so what is this? What was your thinking behind the 2 6?
Well, it takes 2 and then there's 6.
Okay, so you were thinking that this is 2 holes and this is 6 holes. We have to think about that denominator, okay? We have to put the denominator and the numerator and we have to relate them to each other. So if she ran, watch my finger do this. If she ran 2/3, we know she stopped there, right? Because she ran across 1/3, 2/3. Joe, we know, ran the same amount but used the different fractions, so he ran to here as well. They have to stop at the same point because, right, because you ran 1, 2, 3, 4, 5, 6. Okay? Right, and I would just scratch that out and put it over here, okay? Give me a thumbs up if you understand what I'm talking about. Okay, good. So now, when you explain in words, you need to think about what did we just do? And just describe it. Like, what did we just do here and describe it? Okay? So talk about it together. Talk about it together first. Alright, so let's see. Why'd you use the orange piece?
Joe ran the same amount. And Joe ran 6
white pieces.
So are you saying that each of those white pieces might represent a mile?
Yes.
Y'all agree? Okay, so your question was, Anna, she ran how far? No. Okay, you're here. Let's see, Jason ran 3/5. Okay, so show me with your finger 3/5, Demir.
Wait, how many?
Where are the fifth pieces? Okay, so pretend this is the starting line. And show me how far Jason ran. So he went 1, 2, 3, right? So he stopped right here, basically. Alright, now, we're trying to figure out how far Jill ran. What fraction could she have used that also ends right there? Okay, Aria, explain it to me. Okay, why didn't you say 6/5?
Because these are actually 10s. They're 10.
Right. Exactly. Okay, so you said 6 because it's 6/10 pieces, and I love that y'all connected that these are the miles. You're going to need that in an extension activity in just a few minutes, okay? So keep that in mind, that those white pieces are representing the miles. Okay? The trail. Okay, now we need to take it deeper into explaining it. Because basically what y'all said here is you've restated the question, which is good. We like to restate the question so that we know we're focused. But we need to go deeper right here into explaining what happened here. Okay, remember when I had you trace your finger and go across and say, well, they stopped here, and then you traced your finger and went here? I want y'all to talk about how could you put that in words to add to this, okay? So discuss it with each other and come up with something that you could explain how that 6/9 happened. Where did it come from, okay? I'll be back in just a minute. All right. Oh, see, y'all have a challenge here because you had 2 different fractions to find. Y'all had extra people. Now, do we know for sure that David or Rodney, do we know for sure which fraction they used? No, but the question says could have used, right? So we don't know. So here, I want, let's see, Jake Bell, explain to me why, using this model in your finger, why 1/2 is equal to 2/4. You're right, but I just want to see if you can explain it. Okay, why did you point to these first? Why are they called 1/2? There's 2 of them. Okay, so 1/2. So show me how far that was. Because there's 4 of them. Okay. Right, 2 of them. Do y'all see that? Are the same as the 1/2. So when we say 1/2 is equal to 2/4, what's a fancy vocabulary word we could use for that? Equivalent, right? They end at the same spot. They represent the same portion of the whole, okay? So they are equivalent. So what you did just now is you made an equivalent fraction. There are different ways to say different fractions, right? Okay, now, let's see, Josie, explain to me why 4/8 is equal to 1/2. Okay, so you used what you know about 2 equaling the red, 2 white equaling the red, and you have 2 of them, so that equals, okay, so 4 out of the 8 ends in the same spot, right? Okay, good, I like that model, that's very neat, it's precise, you can see everything we need to see, right? Okay, now I want y'all to work together to figure out a way to explain that in words, okay? This drawing looks great, guys. It's precise. Tell me why it's precise, Oscar. What does precise mean? Perfect. Like we have got it drawn to scale so that we can make sense of it, right? All right, I'll come back to just a second. Okay, so, let's see. Yeah, you are. Okay, so numbers. You said, let's read your scenario again. It says Anna ran 2/3. So Drew, show me with your finger Anna running 2/3. Why'd you point to the green? Because there are 3 of them, and so that means there's thirds, right? So she ran 2 of them, so she went from here to here, right? So she stopped right about here, okay? Now, it says Joe ran the same amount, but used a different fraction. Okay, why did you say ninths? Why did you call them ninths? The blue one is 9 what? 9 of these squares, right? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, you're right. So why is 2/3 equal to the 6 ninths? Okay, so it said 3 is equal to 1 green square, and 3 times 2. You see the multiplication there? So look at that. 2 times what? What equals 6? 2 times what? 3. Okay, and then 3 times what equals 9? So we did 3 and 3. So basically we multiplied the top number and the bottom number times 3, didn't we? To get those fractions. Nope, you don't have to write it right there at all. We're just moving towards that. Over here, y'all need to collaborate together, think about it, and figure out a way to explain what we just did here in words. So think about like you're explaining it to a kindergartner. The reason this works is because of this. Okay, so think about you're explaining to someone younger than you that doesn't understand. All right, guys, listen up. Snap once, twice, 3 times. I want you guys to be finished with this in 5 minutes. So what time will it be in 5 minutes, Kaden? 9:45. At 9:45, we're going to start standing up and sharing these things, okay? And asking you questions. So be ready. At that point, you should be ready just to stand up, hold your poster, and explain, okay? 5 minutes. Go. All right. Okay, still. Okay, let's talk about it some more. Let's pretend that you've got a kindergartner sitting right there, and they're going, I don't know what fraction is. I don't know what those pieces are. I don't know, right? Okay, so how are you going to tell them that 2/3 is equal to 6 ninths? I mean, you know it. You proved it right here. 2 of these pieces equal 6 of these. Okay, so you can say what? Okay, write that. I trace my fingers across 2/3. Okay, start there. And then you traced your, well, not the answer, because kindergartner's going to go, what? The answer. So you might say, so Reed's writing, I traced my fingers across 2/3. Now, then what did we do? We did what? Say the same thing. I traced my fingers across what? Okay. And what happened? We got our, yes. But where did we go? We stopped in the same place. Okay, so he just said, we traced our finger across 2/3, and then we traced our finger across 6 ninths, and we stopped at the same place. Okay, so you see how that's explaining what we're doing? I think y'all are thinking that we need fancier words or something. We don't. We just need you to explain why that happened. Okay? All right.
Okay, do you agree that we should, guys, do you agree that we should actually say our problem? Like, Team A is going to be
Well, and that's a good idea because look, everybody will have it. So you can tell them flip their sheets over. Let's all look at your problem. Okay? And then they have it because everybody's going to have that same sheet. So they'll have your problem too. All right. Okay, let's talk about something right here, okay? Are you ready? Y'all look at this picture again. I'm going to see if this can help you, okay? Now, what is right here when we talk about these three pieces, if I say 1/3, what's the relationship between that 1 and the numerator? So we've got like 1/3, right? If this piece right here represents 1/3, what's the relationship between these two numbers? What do they have to do with each other? The numerator tells what? There's one of them that we're dealing with, right? Or that we shaded, or that we pulled out, or that we run. Okay? What does the bottom number represent, the denominator? How many there are in all, right? So, when we look at that, how many of these white pieces are equal to that 1/3? So what would our fraction be though? We can't call it thirds. Because it's not thirds up here. What are those called? Ninths, right? We call these ninths because why, Taylor? Okay, what were you going to say? There's 9 single ones, and we are looking at 3 of them, right? So the numerator is how many we're dealing with. The denominator is how many there are in that complete set. Okay? So thinking about that, and down here, I'm proud of y'all for pulling that out, because that was good. I think y'all was struggling with how to say it, but I think you said it well. Good job.
Okay, so who wants to read the numbers? I'll just
Hey guys, when y'all are looking at this, let's look at this one together. Do you notice any patterns going up here? Okay, so look at this piece right here. There's 1. Then how many are there? 2. Then how many are there? Say that again, Jake. Each thing is getting cut in half. Each thing or each piece is getting cut in half. So look, here's half, and then we cut that half in half, and it becomes a 4. And then we cut those fourths in half, and we have, well, nope, 1, 2, 3, 4. We have 8. Okay, so we go from halves. We cut those in half here, and then here. So we are, do you see the multiplying going on? Times 2, times 2, times 2. When you keep cutting things in half, you're getting bigger and bigger and bigger, right? You're getting more and more pieces. Not bigger pieces, but more and more little pieces. Okay. All right, you guys, I'm 1 minute past, so snap once if you hear me, twice if you're listening, 3 times if your bottom is in your chair and your hands are in your lap. Okay. Bottom in your chair, hands in your lap. Now, it is okay if you are not completely done. We are going to talk about what you have. So we're going to start with the orange trail. So I want the group that did this orange trail right here to come up. And I also want the group that did the orange trail over there to come up. So Oscar, table 1, your group come up. And they're going to walk us through. And I want you guys right here to be ready to give them some questions. Why did you do that? Why did you do this? Think about some of the questions I asked you while you were doing it. And let's see if we can question, and let's see if they can defend it. Can they create an argument to say why they did what they did? Okay? And that goes back to this right here. You see number 3? Construct viable arguments and critique the reasoning of others. That's what good mathematicians do. We want to make sure we can do it. Okay, so starting with Demir, hold up your sign. And Madeline, let's see. Madeline, start talking. What did y'all do first?
First, we knew that there's 10 because there's 10 miles. One block is a mile.
Okay, did anyone else make that connection? That the white blocks represent the miles? Good, you're going to need that in a minute in an extension activity. Okay, keep going, Madeline.
And then we multiplied 3 by 2, which would be 6. 5 by 2 would be 10.
Okay,
That's how we got our answer right here.
all right, good. And what did you say? What two fractions? Because in your original problem, it says that Jason ran 3/5 and Jill ran the same amount but used a different fraction. What fraction did you say that Jill ran?
6
Okay, we said 6/10. So show me with your fingers, run across it and hold it up.
There's 3.
Here we go, I'll hold it up a little higher.
There's 3/5, and then that's 6/10.
Okay, and they both stopped at the same place, right? Okay, did you run into any trouble when you were doing this?
Yes.
Okay, David, what kind of problems did you run into?
Well, we were having kind of trouble determining if we were precise or not.
Okay, if you were precise, and what does precise mean?
If we were exactly correct as the problem in life.
Okay, if we were exactly correct to the model. So we had to do a lot of thinking and a lot of measuring, right, to be precise. Okay, and read the part, Demir, that you explained in words. Okay, so listen, they're saying that 3/5 equals 6/10 because of what they showed you on this picture. Now, Demir, tell us what their words say.
We know that 3/5 equals 6/10 because if you multiply 6 times 2, it equals 6. And if you multiply 5 times 2, it equals 10. Yeah, 3 times.
Oh, they found a mistake on there. Okay. They misread it, but that is exactly correct because if we are multiplying those two numbers by the same number, we are going to get an equivalent fraction. Okay, good job, you guys. Now, let's look at this group. They did the same thing, and let's see if they found the same information. Okay, so, Oscar, here we go. What did y'all do here?
We knew that.
Okay, you guys can sit down.
We knew that the orange has to have 10 white rods.
Okay, the orange has to have 10 white rods. Yes.
And the reds have
The reds. You're right. You're saying it right.
the reds are 2 of white rods.
Right, the reds are 2 of the white rods.
So he got 6.
Okay, so when you went over your 3/5, now there's a little bitty mess up right there with the outlining. Do y'all see it? But they still have it on here. So if we go 3/5, we're going to end at the same spot that we ended on what other fraction? 6/10. You guys did a great job. Okay, so Destiny, read for us what you wrote in words.
The white rods are the 10s, and the red rods are 5s.
Okay, is that correct? Yes. Does anybody have a question? Okay, Jake Mayfield.
Why didn't you guys put the yellow rods? Because those are halves.
Okay. Why didn't you put the yellow rods? Okay, she's saying they forgot them, but
We didn't. They were in the bag, but we didn't notice them that it was going to match.
okay, so he says we didn't really notice them, but any of you, can you tell us why didn't they notice really? Jake Bell?
Because we were talking about putting that much when we were in the group.
Right, because we didn't need those yellow rods, so it wasn't completely important that we had them out, right? How many of you noticed that in your model you had some that you didn't exactly need? Okay, good job, guys. You guys can go and put your paper down. Now, quickly, let's just call one team up this time for the blue trail. Let's do this group with the blue trail. Everybody look on the back of your sheet and let's kind of follow along. Find Team B, blue trail. And let's discuss. Here we go. Who's going to explain?
This is our model to show number form and word form.
Okay. And explain, Drew, how y'all got 2/3 equals 6/9. Why is that true?
Because when you look up there, they're matched.
Okay, they matched. So what do you mean by matched?
That on the line making it even.
Okay, they were even. And even tells us that they are, what's the fancy word? Equivalent. Okay? And Logan, read for me what it says, how you explained it in words.
6/9 equals 2/3 because 6 white squares equal 3.
Okay, great. Perfect. All right, here we go. Take that. Did anybody have any questions about theirs? Anybody think you see anything that you want to question? Okay, Madeline? Okay, why is the blue rod at the bottom? Let's talk about that for a minute. Is that going to change anything?
No.
No, it doesn't matter, but I mean, if we're putting things in order, fine, but it still works the same way with the blue rod at the bottom. Okay? Here we go. What, David?
Did you notice any other trains that could fit with the blue rods? Or were these all you could find?
All these were all we could find.
Okay. All right, and that may be something you can look back on, right? And check them. See if there are any more that work.
The red almost worked.
The red almost worked. Why did the red not work, but it almost worked? Let's see. Drew?
Because it was only like one of them white ones less.
One less. But look at how many white ones are there in this model, Logan? 9. What is different about the number 9?
9's it's an odd number.
It's an odd number, so those little 2 pieces that make up,
They only make even numbers.
they only make even numbers. Good observation. Okay, now let's see, where's our other blue team? Okay, we're going to come out and do this quickly, and then we're going to do our exit ticket, and then I'm going to call some groups, and the rest of you will be working on an extension, okay? So, let's check it out. So, Taylor, tell me, how did y'all decide that 2/3 was equal to 6/9?
Because we traced their finger all the way right here, and it stopped right there.
Okay. Did you hear her say we traced our finger? Many of you probably did that. She says we traced our finger across 2 of the thirds pieces, the green ones. Okay, and then they say at the bottom here they traced their finger across the white pieces. And they ended at the same place. So Reed, what does that mean? They ended at the same place.
They both stopped they're both equivalent and they both stopped at the same place.
They are equivalent because they stopped at the same place. All right, very good, you guys. Anybody have any questions? Okay, Jake Mayfield, what's your question about this one?
Oh wait, I'm just saying that you
Oh, are you just ready to do yours? Okay, very good, you guys. Take that. Wait. Angelina has a question and it looks good. Why is it marked out at the bottom, you guys?
because we got the wrong answer the first time.
But that's okay, because didn't we learn a whole lot because we got the wrong answer? Right, we cleared up a problem, and that's what we're supposed to be doing. Okay, David, what was your question?
I noticed on ours that over here, when we figured out that 3/5 equals 6/10, we 3 times 2 equals 6, and that's because the red rods, these, they equal 2 of those.
You are exactly
but I
right.
noticed on theirs that 2 times 3 equals 6 over there, and that 3 times 3 equals 9 over there, because the green rods that they were using equal 3 of the white ones.
You are exactly right. So you can find the multiplication pattern by figuring out how many rods equal that rod, right? How many 1 rods equal that rod. Okay, very good. So we're seeing if we multiply that top number and the bottom number by the same number, it's creating a new equivalent fraction. Okay, this group come up. Last one. And Ms. Spiegel, would you mind, the exit slips are right over here. If you wouldn't mind in just a second, as soon as we finish this, passing those out for me. Okay, so this group had a different one from all of you. They had the brown trail at Pelham High School. Okay, so Jake Mayfield, start explaining.
First, how we got left order.
Okay.
And these, since these are fours, 2 and 2 gets right in here, so 2 fours is equivalent to this.
Okay, but then they had another person. They had 2 people they had to find. 3 different people using 3 different fractions to represent 1/2. So then what did you do, Jake Bell?
We saw that, well, the 8s, we counted 4 of them, and they equaled two fours, and 1/2, they all were equivalent fractions.
Perfect. So they all
And they
stopped at the same place.
And they all, and we did, and there wasn't a certain one, so we just said which, we just randomly said who was who.
Right, and everybody look at theirs. Look at Team C, the brown trail. If you notice when you read that, what he's talking about is we didn't know who matched up to who because it said David used a different fraction and Rodney used a different fraction, but it did not say specifically which one. So they just kind of had to assign one to that person. Does anybody have any questions about this one? Oh, Riley. I mean, not Riley. Harley, tell us what you wanted to say. Yeah, she's going to read the words.
If you ran 1/2 of the trail, Rodney could have ran 2/4 of the trail. David could have ran 4/8 of the trail because if you cross multiply, you will get the sum.
Okay, so she even took it up to cross multiplying. And remember, we talked about that some of us know about cross multiplying, but on cross multiplying, it's hard to explain it, right? It's hard to show what you did on cross multiplication. So that is a strategy for solving, but it's hard to say why it happened. Okay, so that's one thing. Anyone else have a question about this group? All right, very good. You guys can go sit. And Miss Spiegel is coming around with your exit ticket. What you're going to do is you're going to do it really quickly for me. You're going to come up here and put it in the exit ticket box. And then I'm going to be passing out an extension activity. For the extension activity, you're going to work together. But I'm going to be over here working with a group of people that I call over. So you are going to be working on this, okay? But you're going to be able to talk and use the people at your table. I've also put some graph paper in here for you, okay? So table 5, here's yours. Table 4, here's yours. Good, I can just sit there, it's fine. Table 3. Table 2. And table 1. Okay, so do this exit slip, that's what you're working on, and then after you do it, put your name on it. You're going to bring it up here. Well, it's similar. You're going to use the same thing to do it, and we're going to go put it in the red box, okay? All right, working on your exit ticket independently. All right, you guys.